Hello everyone. So back with another video on void cuts again. This time we are going to be looking at a cylindrical void cut. So a little bit different from the other video where we were looking at rectangular void cuts. There's a whole tutorial on that, 20 minutes long, but we talk about various things and how this can be used and etc. And in this case, we're just going to be looking at like a cylindrical double, like a double cylindrical family here, which is kind of specific to this T-connector that we're doing. But you can imagine something like bolts being used for it. You can also just have the hole go all the way through. So, for example, if we change the diameters to be the same, then you just have a hole going through. A little bit of an X here to help you with positioning and maybe checking dimensions or anything like that. So you have something to snap onto, which is quite nice, or aligning it to the center. And maybe some other weird kind of shapes. So you could have something like this. Don't know what you would use it for, but could be possible. Something like that. But mainly it'll be sort of like a passage hole for connecting elements together. And for some context, could be something similar to this right here. So, these type of holes like that for putting the dowels in this case. So holes that go through a beam. And why would we want to use this? Well, if you are having to provide a reference model for manufacturing, if you are responsible for this, if you have to provide the sort of like manufacturing ready model to the supplier, this is just highlighting that you can do it. It's possible, and the various different ways. So in this case, like where we have this T-connector, I wouldn't necessarily do these independent, probably build a bit more of a clever family. But having this just in your tool set, in your families is really valuable. It can come handy for a lot of different other things. Another example that just came to mind is if I take this family and I just pick a new face, put it on here, and let's say I want my host width, which in this case is going to be the depth because that's the face. I don't know, let's make it 400. And let's make the shaft diameter 10 and the countersink diameter, let's make it 30 and the depth, yep, something like this. And cut it. And this is not an instance-based parameter, so sorry, a family. So we don't have gripping points, where here we have gripping points. And that's just by choice. We could have made this a family. Is a bender for reference, as usual. 2 meters tall, so that's quite high. But here, what I wanted to kind of do is actually just make this a little bit longer. Let's go 600. And it's kind of cheating a little bit because we are not cutting all the way through. But here we have some sort of unique detailing where we could maybe have a screw that goes in there, and then it could be like a deflection kind of detail. So where the beam is deflecting down, the screw head is like popping up a little bit, something along the lines of that. So lots of different uses really that it can be used for, and it is a face-based family. So we're just putting it on different faces. Pick a new. It's already cut, so it doesn't like when it is cut, but if it's uncut, we can just put it on any type of face that we like and cut it. Then we have our beam with weird holes in it and stuff. So you can do kind of like complicated things in here, complex things, I would say. Okay, cool. So let's get into it. This is a face-based family. So let's go here. As described in my other video as well, you can do this as just a generic model normal family, but then you will struggle a little bit to kind of like create some intelligence with the locating of the void cut. So 90% of the time, 95% of the time, I'm wanting to position it onto a face so that I can create some sort of intelligence. So we just start with a very basic generic model face-based family. And in here, we can see the reference. We have 2 cylinders and a shaft. Well, two different cylinders, well, 3, but 2 of them are the same. And this is like a countersunk kind of counter bore cylinder. And it has obviously a diameter, a depth on both sides, and these are equal distance. And then the shaft in the middle is a relationship to it's going to be a factor of the depth of these two together. So let's see how we do this. Okay, let's start. Here we are in our the opening screen of the face-based family. I'm assuming that you know a little bit about Revit already. If not, as always, let me know and I will create a video, or maybe I have at this point in time, who knows. But essentially we are on the reference level. I like to just change my screen a little bit. Was working consistent colors. I like to move this out the way. This object here is representing the face that you will position the object onto. So that is the face, the reference plane, let's say, and the plane could be anywhere. It could be a wall, a floor. In our case, different faces of a beam element or a column or anything like that. So if we think about then, what do we want to be protruding into our face? We want the holes, the cylinders, to be going down into the face. So then we're in our top view here. We can just create a void extrusion and a circle. Let's just make it a little bit big to work with. I'd like to add the center mark visible for this so that we can actually lock this to the center point planes. And we want to start creating some parameters to manage our size of our object. So just create a diameter dimension, and let's create a. You could do an instance of type, but in this case we want it to be a type because we're expecting to use the same type of type in lots of locations. If you had a project where you were you knew that there was going to be lots of different variations, then probably instance would work a little bit better. When creating these, it's good to kind of think about how is my family going to be used. And more often than not, you may create 2 different variations, one where it's an instance type of family and one where it's a type of family. So actually in this case, I'll make an instance one because I have the type one, and then I can show you a comparison. So let's do that. Hole. So what type of hole? It's the countersunk, and it is the dia of that. So I'm going to copy that before using in a bit. So that's good enough for now. Let's create another one, because this is going to be, let's say, the countersunk diameter, so the big one, which is that one there. And now we want to create the shaft. So same process, void form. We could copy and paste it, but let's just do this from here. You can't align this if you don't have the center point, so that's why we added the center mark visible. And good to keep these things associated because now we know that both of these cylinders are locked to the same plane. And a similar process, we want to create a diameter. And let's call this one hole, but it's not the countersunk. It would be the shaft dia. And again, let's make this an instance parameter. Okay, that is great. So let's now move into a different view, because from here we have to set the depth, but also we have to copy another one. Actually, we can copy. Let's copy it afterwards. We have to mirror or copy the another version of this countersunk shaft, countersunk void cut to represent the other side of the element. But it's better if we do it in another view. So let's use front view. And here, let's just set our view up a little bit. Shaded, no, consistent colors. I always remove the reference level out of the way. Actually, I haven't done it in this case because I don't want to associate to a reference level. I want to associate to the reference plane. Okay, so now we have to create some, we always start with either a reference line or reference plane, and we test if that's working. And then we lock our geometry to the reference plane or reference line. So there's a hierarchy to this. We want to create the kind of framework for the geometry to be associated to. So an interesting thing here is if I create reference planes, we won't actually have any gripping points to pull and push in 3D. We'll have them in 2D and elevations, but here we can kind of see that we don't actually have any gripping points, where here we have these gripping points that we can work with. And we have these because we use reference lines. Reference lines allows us this functionality. I don't know if that's its intended use, but that's how I've learned and how it works for me. So what I'm doing is thinking about what do I need to set up here? So I need one location, one area, one depth for the first countersunk void element, and this is the one that's going onto the plane. So if we look at it here, we can see if I uncut this. So when we're picking the plane, you see that X is showing that's the that countersunk cylinder that we're working with now that will go into the reference plane. Yep, so that's that one there. And before we carry on, let's create some parameters. So we want these to be the same, and we want these to be the whole. We got this already countersunk, and this will be the depth, like kind of the cutting depth. And again, we want that to be an instance parameter. That's good. And let's just test that. Okay, that's good. Let's do the same for this one. Constant hole depth. Okay, so these are working pretty good. Let's lock this to that. Give this a test. Okay, looks good. Now we actually need this one to be down here. I'm just going to copy it to the side and just going to check if by copying it we haven't lost our association to our diameter. So whole countersunk diameter. It's always good to test things. Looks good. While we're here, let's test the diameter of the other one. That's good. Great. Okay, so then we can lock this one there, and we can lock this one there. And now we want to lock this again to this top plane. So we go to the top view, and we can just do this, lock it there, grab the reference plane, lock it there, and that's that done. So now we have to get the shaft, and we don't actually need any parameters to handle this because the shaft is constrained between these two elements. Well, actually, that's not true. It's not yet constrained, but we're missing another parameter here. So if we look at this object, we want to be able to control how far it protrudes in. And I try to look for interesting ways to create like a reporting parameter that can find the width of the element or the depth of the element that you are connecting into. But reporting parameters, as far as I understand, work for hosted families. So for example, walls. So you can't actually extract information from the element you put the object onto, if that makes sense. I thought, let me try be clever and let me try bring a beam into a structural framing into this family and then map the width parameters through. But I get an error because a structural framing is not a host family. So you can't actually do that. If there is a way that you can do it, I would really love to know. It could be a super interesting way to make this family or lots of different families of this type way more powerful. But for now, what we will do is we will just create a host depth, just host depth, I think is good. And we can make this instance as well. Why not? Well, we should, yeah. So we can push and pull this. So now the, let's just make this, let's say 400. Just check that it's working, 500. Yeah, it's good. So now the distance between this line and this line is determined by these two figures minus that. So there's no sense in creating an additional type of parameter. Maybe you could create a reporting parameter, but for what reason, I don't know. I mean, it could be if that's what you would like, but so we got this. That's cool. And that's what that looks like here. I'm not sure why that goes all the way over there, but it is all the way over there. So that is mostly it. There's another thing that I would like to add, but I'm going to first show you why that could be important by not adding it and then working with it. So let's just save this as a family. Let's call this an instance version and load it in. I broke my file earlier by trying to group these elements together and then rotating them. I wouldn't suggest it. Okay, cool. So let's put that in over here. And actually, this is not going to work for initially, but that's great because I can show you how it doesn't work. So if I try to cut it, you can see I actually can't select it. Whereas with this one, when I select it or when I go cut the object to be cut, the cutting object, you can see it highlighted and it cuts it, whereas here it is not doing that. And that's because I forgot to tick a box. So we have to tick this box. And load it back in. So now we should be able to cut it. Yep, look at that, super cool. Yeah, really cool. So let's say, I'm going to delete these. Let's say I want to align. By the way, I'm going to use some hotkeys. So I use Shift S to isolate objects, which is incredibly handy, and Shift E to unisolate. So instead of going here, it's like super great. I also use the A key as align, which you can find over here. I never use it, so where is it? There. It's AL out of the box, but I've put this onto A because I use it. It's one of my most used commands. So we want to align this cutting object to this point because what we're trying to achieve is we want to cut this beam. It's Glulam beam because we have this nice T connector, concealed connector, and we need to cut it. So now we have a little bit of an issue of how to align this. So perhaps I can find that line, which is quite nice. And I have some points to choose from. And in this case, actually, that works pretty well because I have the reference plane and I can align it there. But it's only because I've added these little extra lines inside of this. It's not even family. This is just the in-place modeling. It's for a different tutorial on kind of like the lowest level way to model this thing. But I've added that in because if I didn't, then it's a little bit difficult to align this. Let's try. And in fact, let's uncut it because maybe that's why it was working nicely. No. So yeah, you don't really have a kind of a center point to connect to. You can do it there, but then you need to move it. So a nice little tip is to, well, inside of the family or inside of the this I've double clicked in to go into kind of like the massing environment where I can manipulate this. Then you can add a line in there that will be shown in the 3D. Or inside of the family, we can just add a little line as well. I'll just type LI, so symbolic line, and just align that. Align that. And you could also make sure that, that it behaves well by doing it here as well. Remember to select the correct object. Model line reference, yep, looks good. And load that back in. And then we have a nice X to work with. So let's see what this looks like. Consistent colors, there we go. So with this, we're also able to then do, kind of, oh, what happened there? Bit of a glitch with my graphics. But you're able to then take advantage of using the dimensions for locating this thing. So that's quite nice to have. And constraint, please. The other thing that we wanted to look at is the gripping points. So here we can see them. First of all, let's just make this 200. And so the way that this is working is because we have, we don't have all the gripping points because we've connected this to a reference plane. So there's an example of where without a reference line, we could maybe do a bit of a hack. Let's try. Why not? Where we actually, this feels a bit cheeky, but we're going to take a reference line. We're going to break this. We're going to snap that on there. Then we're going to align that and lock that. And just double check if this is still working. So now our, it is quite cheeky, this. And maybe it won't work. Yes, I think that this won't work. We have to find our reference line there and connect the dimension to that. And this is our countersunk depth. Okay, let's see if this is going to go the right way. Okay, kind of looks like it's okay, but let's see what happens. Oh, okay, so it's worked, but for some reason our I wonder if, I'm not sure why it's up over there. Maybe I'm not sure what determines where these gripping points land or start. Could be that that needs to be maybe there. Not sure. So the answer is yes. That is what determines where they are. That's nice. I've learned something as well. That's great. It's the beauty of making videos and tutorials. You learn by doing. So if I actually move these there and move, that one's already centered. I think this one kind of looks centered, but let's just move it out. So now in theory, our gripping point should all be nice and centered, right? Did I miss one? Oh yeah, I did. I'm actually really happy that I learned that because I never thought about that before. So here we have the gripping points and we can play with them a little bit. But as you can see, obviously it's not parametric to the center of the beam, or in this case, because we're going from the plane. So it may not be useful, but it's cool to know that you have these points. You could make, like, for example, the inner ones you could have as instance parameters on reference lines. And then you could have the external one here as a reference plane. So let me show you. and that could work pretty well. So let's delete that. Let's create a reference plane, and let's associate that. Let's get our dimensions back, our parameters. You and you both need to be depth. Oh, sorry, that's already depth there. So you need to be depth. And we need one more from there to there. And you need to be the host depth. Great. Let's load that in. That's fun. But yeah, so that could be kind of cool as something to play with. And of course, these are the same parameter. That's why they're moving together, but you could have them unique for different reasons. And let's say 200. So that means that kind of like the, even though they're still instance parameters, you can't change them via the gripping point. But you can change that one via a gripping point. So that's kind of cool. And let's do this just for some fun. I mean, you really can do so many cool stuff with. So now if you had the other gripping point, what if you go like that? No, it does nothing. It just breaks it. But of course, this is an instance one, so we could just put that there as like 1 meter, 1000. You know, now we're starting to create some funky looking things. Could align it because we have our aligning points. Even lock it so they all move together. So yeah, you can actually create some cool configurations with this. Even little recesses there. So that is it for this video. Just another way to use void cut families, and specifically for this case, it's for Glulam connectors. And the reason why this is getting made is because I'm making a bigger video where I actually go through the creation of this type of connector. Not these ones, but something like this Alumidi type of connector. So it's just a variation of this, a simplification of it really, because this is kind of a cool connection. And there's so many different types of this, but I wanted to just show one and then different progressions of it perhaps. And in order to do that, we needed a family that shows how to create this little dowel hole or bolt hole void cutting family. So that is it. If you like the video and if this is useful, yeah, give a like, leave a comment on if you have any questions about this type of family. I use it a lot, particularly for like fixing screws and stuff like this. It's very handy and useful. I will start to collect these families, and they surely will be available at some point on a download for download on a website or in some sort of container. But if you really would like it, in the meantime, please reach out and I'd be happy to share it. Great. Thank you so much for watching. Enjoy your day and look for the next video. All right. Bye.